So let's move into talking about slope of a line. And you've probably all thought about slope before, for example, if you're sledding or skiing down a hill, or the slope of a roof. And it's really the same thing when we talk about lines in graphing. So the slope is a measure of steepness. And when we look in math at graphs, a slope can be positive. Okay, so this first example here, where from left to right, we're going up, or negative. So from left to right, you're going down. Zero. Okay, my student told me that you can remember the slope is zero here because it's no fun to ski. It's zero fun to ski. Or undefined. You can't ski it when it's totally vertical. So that's how you can remember. Zero is your horizontal line, has zero slope, and a vertical line has an undefined slope. Slope is really just a ratio of how much the line rises compared to its horizontal change, which is known as its run. So slope is the vertical change between 2 points divided by the horizontal change between those same 2 points. And so you can kind of abbreviate that as rise over run. A couple applications of slope. Roof pitch is one. And so typically people measure roof pitch by a number in 12, which means the rise per 12 inches of run or horizontal distance. So if a roof has a pitch of 4 in 12, there's a 4-inch rise for every 12 inches of run. Percent grade on a road is another example. And so for every 100 meters or 100 feet of horizontal distance traveled, there is, if it was an 8% grade, there would be 8 units of rise over that same run. So 8 feet rise per 100 feet of run, or 8 meters of rise per 100 meters of rise would be the same ratio. So it's a measure of steepness. And most major highways have a maximum grade of 8%. And grade is also really important for rails because trains can't handle very steep grades. Okay, so when we're going to calculate slope, what you can do is choose 2 points on your line. So here we've been asked to find the slope of this line. Choose 2 points that are on grid lines. So here I have them marked 1 and 2, which is arbitrary. We could have labeled them 2 and 1 and we would get the same result. But we're going to label them. And then we're going to calculate the rise between the points. So when I go from point 1 to point 2, I have to go up 3, which means my rise is positive 3. If I had to go down, it would be a negative number. So here we have a rise of positive 3. Next, we're going to measure the run from 1 to 2. If we're moving to the right, it's positive, and that's what we're doing here. So we're moving 1, 2, 3, 4, 5 units over to the right. So our run is positive 5. Okay, and so then you're just going to calculate your slope by rise divided by run, which in this case would be 3 over 5. Just to show you that it doesn't actually matter whether I pick what I label as point 1 and 2, let's just switch it up. Maybe I'll change to purple now. So what happens if I made this my point 2 and I made this my point 1? Well, my rise is going to be what? I'm going from point 1 to point 2, so I have to go down 3. So my rise is negative 3. My run, slope is rise over run. So my run from point 1 to 2, I have to go 1, 2, 3, 4, 5 over to the left, which is negative 5. And so my negatives cancel, and I end up with the same result that we got, which is 3 over 5. So that's why it doesn't actually matter which point you choose as 1 and which point you choose as 2. Another way to calculate slope is using the slope formula. And so what this says is choose your 2 points as x1, y1 and x2, y2, and then you can plug them into the formula. So here we've been given 2 coordinates and we want to find the slope on the line that would be drawn between them. And so I always label them, and usually I just label them above. So in this case, we're letting a to negative 4 be x1 and y1, so that's our point number 1. And then we're letting 2 comma 6 be x2, y2. And just like in the previous example, that is arbitrary. We could have labeled a to -4, x2, y2, and 2 and 6, x1 and y1, and we would get the same result in the end. But it's nice to label them to be consistent. And then we just have to plug them into the formula. So slope is y2 minus y1. So in this case, that would be 6 minus -4 over x2 minus x1, so 2 minus 8. So we end up with 6 plus 4 gives us 10 divided by -6, which we can divide both of those by 2 to end up with -5/3. And just remember with negative numbers, -5/3, where you have the negative in the middle, means the same thing. I guess I didn't really put it in the middle there, did I? That's more at the top. So you can either have that negative in the numerator or in your denominator or in the middle before the fraction, and all three mean the same thing.